special products that now we call them factoring. Remember, when you go from right to left, it's called multiplication. Left to right is factoring. And so, if we know special products, therefore, we should know special factoring. And there's really no way around it. We should memorize it. For example, we said a squared minus b squared is a plus b times a minus b. So if you happen to have two terms and they look like a difference of squares, that's how you approach it. For example, we looked at x squared minus 25. So it's x squared minus 5 squared, right? We looked at other special products known as special factoring now, like a perfect square trinomial. We looked at difference of cubes. We looked at different sum of cubes. And so for the difference of cubes, for example, we looked at 8x cubed minus y cubed. It is important to put that in the format of a cube. So it's 8x cubed becomes 2x quantity cubed. So if you want to compare that to the third one, you see your a is 2x and your b is y, and all you have to do is just wherever you see a, plug into x, b, plug in y, there you have it. We looked at a perfect square trinomial. If the first term is a perfect square, if the last term is a perfect square, one easy way out would be to look at this format. You say the square root of x squared is x, square root of 25 is 5. We have a positive sign. Let's go with the positive sign. And you must check the middle term. And that works. Now, with that, I want to add a couple more questions. And that would be it as far as factoring. By the way, there is a workshop at 2:30. So let us look at this example that was asked. We have 8. Again, this is questions from the student. I don't know, is this from your take-home test? Is this from the take-home test class? Yes? Okay. Actually, this is just the same as what we have over there. Okay? So this is what? 2w cubed. Do you see that? And this is minus what? 3 cubed. So it fits into which pattern? Again, it's the third one, isn't it? So you open up a couple of parentheses, and all you have to do, say, okay, now A is 2w. Right? Think of 2w as A, and 3 as B, and plug it in. A minus B gives you 2w minus 3, right? Right, class? Now, if you want to take this step, you can do that. A squared, so 2w squared. Then what do you have? Plus A times B, plus A, which is now 2w, times B, which is what?
3.
Plus B squared, which is what?
3 squared.
And now, just simplify as follows. Now, this step with asterisk next to it, you don't have to write it if you are comfortable with it. If you have any doubts, don't skip this step. Okay, this is a very important step. Simple. And it's just all you have to do, just practice on that. I can do a couple of them, but that's not enough. You have to do many more. Does that make sense? Okay. Let me quickly give you one more example of that and see if you can come up with the answer. How about 64 plus 125 m cubed? Why don't you try this on your own? And all you have to do is figure out which pattern it fits in. And what is your A, what is your B, you have your answer. Go ahead.
The 4w squared, we don't factor that out? Or do we?
What do you mean? You're talking about the whole thing? Factoring this piece? This can't be factored out. It's a prime polynomial. When you use that, this can't be factored out. By the way, one thing that will help you see factoring is b squared minus 4ac, which is the discriminant. Do you remember that? Discriminant? Quadratic formula? Anybody? Nobody. Wow. And you don't remember the quadratic formula? You don't remember this one, class? Ax squared plus bx, and I went over that myself. You remember x is equal to what? Minus b plus minus the square root of b squared minus 4ac over 2a. You remember that? You've learned it in elementary algebra. B squared minus 4ac is called the discriminant. When you calculate b squared minus 4ac, if it happened to be a perfect square, that means it comes out, right? For example, if it's number, 25, comes out as 5, right? When it's a perfect square, if you calculate that, that means factoring is possible. In the case of a trinomial, is everybody with me? In the case of a trinomial. In any event, what does it look like? This looks like something cubed plus some other thing cubed, right?
4 cubed.
This is 4, and this is what?
5.
5.
So all you have to do, look at the patterns. Which one does it look like? First one, second, third,
Fourth.
fourth one. So just copy it into the fourth one. Wherever you see A, you put 4, right? For B, you put
5m.
5m. Go ahead and do that. Give me your final answer. So what should I put here?
4 plus 5m.
4 plus 5m. Okay, so that's A and B. Now what do I need?
16.
16, which is A squared, right? What do I need next?
Minus 20m.
Which is minus A times B. Finally, what do I need?
25m squared.
Which is plus B squared. So I hope you realize it doesn't matter what I do. If I don't know the pattern, if I haven't memorized, I'm going to have a hard time doing the factoring. I have to memorize them, and there's no way around it. Sounds good? Now, of course, the beauty of math is that you can check your work, right? Everybody knows how to check it. How do you check your work? Just multiply it through, and it must give you the original expression back. Otherwise, we've made a mistake somewhere. Does that make sense? Good. So, I want to add a couple more questions. For now, I'm going to leave the special factoring. Okay, x to the power. Okay, this is an interesting question.
Here's a question.
And by the way, we always do complete factoring. Okay, class? Find the value of c such that the system of equations what? Isn't this the same question we did last time? such that the system of question what? There's something missing, okay. The system of question, it's what? Inconsistent, is that the question?
No, it just says find the value of C such that the systems of equations does not have a solution.
Does not have a solution, because I didn't, okay, such that the system of equations, okay, no problem, we will look at that when we get to the system.
Thank you.
So x to the power of 4, everybody, minus 81. Let us look at this one. And when we say factoring, we always mean complete factoring, okay? Now, the very first thing is to figure out which pattern this one falls into. 1, 2, 3, 4. By the way, 2 has 2 parts, okay? So what does it look like? The first one? Okay, the difference of squares? Sounds good to me? Okay, what do we do? Something squared. So what is being squared here? Again, this is a good step to keep. You really don't want to skip that unless you are absolutely sure that you know what you're doing. So what do you square to get x to the power of 4?
X squared.
What do you square to get to 81?
9.
All right, so what do we have here? Can you tell me, looking at the first pattern, what do you have?
X squared plus 9.
X squared minus 9.
Okay. So far, so good. By the way, if you wrote x squared minus 9 first and x squared plus 9 second, it makes no difference. Now, remember when you do factoring, you're supposed to do complete factoring. Are we done? Good. What do we have to do?
Factor out x squared minus 9.
So it is clear that the same pattern works on the second piece, x squared minus 3 squared, right? So what is that?
X plus 3, x minus 3.
Does that work for everybody? All right. So if you happen to have a case that fits into one of them, see if you can continue in the case of, for example, difference of squares, we can do that. All right. A couple more questions for factoring, just to make sure we're in good shape. I made some changes because I didn't want to do the same questions. I want to remind you of grouping and then substitution method. So let's look at the grouping. So I'm going to erase this. I hope you have memorized it. If you haven't, you make sure you do it by tomorrow. And this is not going to go away, by the way. If you honestly learn Math 130, the intermediate algebra the way you're supposed to, you're going to have an easy time with any other courses, even science courses, okay? Because this is the base of almost every course that you take. All right, so let us see a couple more examples. Let's see. We have the following. 5 BC minus 10CX minus 7B1 plus 14X1. And we're going to see if anything works out. Now, remember what we said. If we have more than 3 terms, that means 4 or more, there has to be some sort of a grouping. In this case, let us group the first 2. Anything in common?
5c,
What do you get?
b minus 2x.
Does that work for everybody?
Yeah.
Okay, last 2. And remember, we are hoping we get the same parentheses here, right? That's what we are shooting for. So anything?
Negative 7y, parentheses b plus 12, no, minus 2.
The reason it's negative because you took negative 7 out. And so the 2 parentheses are identical. Just write it. And the first one What is left of it?
5c negative 7y.
Second one, negative second. And if I have any doubts, what do?
Well,
Multiply, make sure I have the original expression. Simple, as far as checking. Grouping work, and again, if I did the first two and it didn't work, then I have to check the first and the third one, first and the fourth one, something has to give, if it's supposed to be a factorable polynomial. All right, let's look at one more example, which is by substitution. All right. What you can do, there are two ways. One way is just to square this, simplify it, and do the factoring. One way is by substitution. Which is a very powerful tool in math. So let y minus 4 be represented by anything except y. You can set it equal to y. You can set it equal to x, m, z, you name it, u, okay? Any variable. For example, let's say it's x, okay, class? So let's see what we did. Now, we can rewrite this as what? 2x squared plus 5x minus 12 is that right?
I'm sorry. So what's
Let
the
y plus 4 be anything you want. So y plus 4 is replaced by your choice of variable. In this case, it's x. So 2x squared plus 5x minus 12, which is a constant. Do you see? Is everybody okay with the way we did the substitution? If I had chosen a different variable, let's say z, let's say m, let's say u, then it will be 2u squared plus 5u minus 12. Okay, whatever the choice of variable is. Go ahead. Just make sure not to use the same variable that you have here. Go ahead.
When it comes to substitution, should you FOIL it or should you replace the value before you FOIL it? Or does it make a difference?
No, you shouldn't. You shouldn't FOIL it. If you're doing the substitution is supposed to make your life easier. You don't want to simplify it. Don't want to FOIL it. Before you do that, you want to do the substitution. At the end, there is no need to do the substitution. The substitution takes place now. Everybody understood the question? If I say, okay, let me evaluate y plus 4 quantity squared. Let me multiply it by 2, let me distribute to 5 and combine like terms. There is no longer any need for that. Is everybody okay from here to here using the substitution?
I'm sorry, in the blue part, y minus 4 equals.
Y plus 4, I'm sorry. Y plus 4, I got it. You're right. Y plus 4. I was putting y minus 4 to see if you're checking, if you're paying attention. You know that, right? If I ever make a mistake, it's all your fault. So, all right, so 2x squared plus 5x. Now let's do it by any method. For example, the easy way out would be the trial and error. 2 is a prime number, so we go with x and 2x. That's fairly simple, right? So all you have to do, look at number 12 and cut it into pieces. By that we mean factoring. Don't forget it's negative, which means one of it must be negative, right? Remember, 12 gives you 1 and 12, 2 and 6, 3 and 4, right? And you want to put some sort of a combination that works, right? So you are working on the constant c equals negative 12. Anything will give us the positive 5x, anybody? And you see, this is a trial and error.
8 and negative 3.
What should I write here?
8, negative 3.
That's
And
eight.
negative 3. This is negative 12. 8 times negative 3 is negative 24. So I'm looking at just negative 12. If you want to multiply it by 2, which becomes negative 24, that means you cut it into pieces and you have to do with grouping. I'm doing by simply trial and error. So I won't look at 8 times C, I just look at C in this case. You're right. If you want to go with negative 24 and that works, then you have to change the 5x to those two pieces that you mentioned. So just looking at negative 12 with two numbers here such that the middle term becomes positive 5x. Do you see that? Yes.
Well, aren't you supposed to multiply the first and the last term together, which would give you negative 24x squared with 5x, and then you can find 3 and 8?
Yeah,
No,
that's
I think.
another method.
That's another method.
It's the same, you should use that equation, right?
I said there are two ways that you can do it, right?
I just do plus 4.
There are three
We're
ways.
doing substitution.
The trial and error, you don't look at anything except C. If you're looking at the trial and error, you don't multiply by 8. Okay? And negative 12 would be 1 and 12, one of them negative. Which one will figure it out? 2 and 6, one of them negative. 3 and 4, one of them negative. And that's all you have to do. Then you make sure the 5x is, acquired. You understand what I'm saying? As I can see that you need to practice a lot, class. Okay. This is the first method. I will look at the second method because I think you need to see that. But can you see anything can work out here?
2 and 6.
2 and 6? Where do you put the 6?
The first.
The first one?
Yeah.
Okay. If you put 6 here,
Positive 6.
positive 6?
-2.
Okay. Would that give you positive 5x?
No. Nothing works.
It's very easy to see. I'm surprised that you guys don't see it.
Minus 3 plus 4.
What do you see? You see what number?
Plus 4?
How about that? Positive 4 and minus 3. Is this positive 8x? Is this negative 3x? Do they add up to positive 5x? It's a trial and error. You look at numbers and the numbers speak to you, if you speak the language, of course. Right? It is up to you to see it. It's just a matter of practicing. Now, what you had mentioned, I want to mention that since a couple of students brought this up. And by the way, when you get here, let me finish that, and then I look at this one, a second method. This is not finished because nobody cares for x. Why not? Because the original expression doesn't have any x. We did the substitution. You have to put the x back. What do you put in instead of x? Y plus 4. Do you see that, class? And I'm not finished, but I just want to, we are not finished. I just want to make sure you understand that x, we did the substitution, we used the x to make our life easier as far as factoring is concerned. The final answer doesn't involve x at all. So the final answer is that you replace the x with your choice of x, which was y plus 4. And so this one becomes y plus 8. Is that right, class? This one becomes what? 2y plus 8 minus 3, which is plus 5. So y plus 8 times 2y plus 5. If you simplify this and collect like terms, if you multiply these last two, you get to the same answer. Do we see that? There were some questions on your sample test as far as substitution method is concerned. Since some students were getting confused here, let me just quickly mention the second and the third method to refresh your memory. Okay, if you are factoring 2x squared plus 5x minus 12, what you looked at was called the method of trial and error. You just picked up the numbers and did it in your mind. And the way it works, class, you look at A and you look at C. That's all you look at. A happened to be a prime number, which makes it easy. There's not much we have to do. But C is not a prime number, so it has different factors. It just makes it a tad longer. Is everybody clear on it? So that you're done with that, and the method that was explained. The second method, which was by grouping, you look at A times C, and now you say you want two numbers, right? Such that the product is AC and the sum is B. Right? What are those numbers you were saying?
8 and negative 3.
8 positive and 3 negative, right? The product is negative 24, the sum is positive 5. Therefore, what you do here, class, you change the 5x to plus 8x minus 3x. Do you see what happens here? This goes away and it becomes 8x minus 3x for the sake of grouping. So if I group the first two together, what comes out?
2x.
Times what?
Parentheses x plus 4.
And if I lump together the last two terms, let me use a different color. If I put together these two pieces, what comes out?
Negative 3
Times what?
x.
And that gives you the same thing, right? That gives you the same thing. X plus 4 times 2x minus 3, doesn't it? So, don't mix up the two methods. The trial and error, you do it in your mind. Grouping, you have to come up with numbers. The third method that I mentioned this. Remember that? So you go back to the original, which was 2x squared plus 5x minus 12, and you say 2x, remember that? 2x over 2, right? Now, remember these numbers that you got? Just put them in there. But it doesn't matter where you put them, because both of them start with 2x, don't they? Do you see what happens here? This method will help you in the sense that it doesn't matter where you put the numbers you came up with. You don't have to guess. You don't have to look at the middle term. And now, do you see the first two terms, the first parentheses, the first two terms? This one I can cross out, and I say 2 times what? X plus 4, right? So the 2's cancel out, and we end up with x plus 4 times 2x minus 2. Is that making sense? Fairly simple?
I'm sorry, what is this third method called?
It is really an extension of that grouping, okay, as far as I can see. Because ultimately, you really need, you can call, even the first one, they call it the grouping or the AC method. You can call this the AC method. It's just, it works. That's all that matters. Sounds good? All right. That's as far as factoring is concerned. Let me just also come up with another example quickly. If you happen to have the following case, let's say x to the power of 4 minus x squared, let's say plus x squared and minus 2. All right. If you want to factor this out, class, you have two choices. You can do it just the way it is, or you can do it by substitution. The way it is, some of you may recognize, it is doable if you just realize this is x to the power of 4, so you don't put x and x. Rather, you put what? x squared and x squared. Do you see that, class? And then treat it like a basic trinomial that you've seen. Can you see that? If not, you have to let x squared be something. For example, y. I'll explain that one too. If you go with this route, you are looking at two numbers, the product is -2 and the sum is +1, right? What are those numbers?
2, -1.
What do we have here?
+2,
+2?
-1.
Now, I'm not finished. I'm going to continue in a second, but do you see how fast it went? Or if you want to go with the substitution, let y represent x squared. If you go with that case, do you see you get y squared plus y minus 2? Do you see the one in red? And then you factor it, which you already know how. It's a simple case of a trinomial. And then replace the y with x squared. Now, in other words, the red one becomes what? Y plus 2 times y minus 1. Is that right? Which, of course, is not finished since you have to go back to the original variable. All right? So no matter how you do it, you end up here, right? Are we done? What's the final answer? You look at the last piece, you see the first parenthesis is okay, the second one is what?
X + 1, x - 1.
And class, order is not important because now you have three, if you will, pieces that you're multiplying, therefore you're dealing with associated property of multiplication. It doesn't matter which piece comes first. By that I mean which parentheses. All right. I want to go and discuss system of equations, but before that, I want to spend a couple of minutes on a question that came up, something that we have worked on previously, and it's part of really this exam, exponential rules, which really is section 1.5 of the course. So just to refresh everyone's memory. Class, a to the power of m times a to the power of n is a to the power of n plus n. Everybody remembers that, right? Okay. I mean, if you don't have to write that if you know it. I have gone over that. It should be in your notes. And a few more that I had given you last time. So a couple of questions that I want to quickly look at. There was a question regarding negative exponential groups. So okay. A few questions that came up. Something as simple as, let's say, 2/3 to the power of -2. Let me just write that one. Let's say the cube root of -64, and what is something like a to the power of -2b, or let's say y to the power of 5 over, okay, let's put 7 here and 8 here, a to the power of 5, b to the power of 7, y to the power of -5, the whole thing to the power of -2. Let's say we just made up something. All right, some negative expansions that students have found. First of all, if you're looking at this one, this is simply 3/2 to the power of +2, isn't it? Which makes it what?
9/4.
If you're looking at this one, a cube root, what does it mean? I'm looking for a number. I multiply by itself how many times?
4 times 3 times.
3
4
times in
yeah.
order to come up with the answer. Now, everybody knows that 4 cubed is 64, right? So this must be -4. And let me just make sure everybody understands. the difference between an even and odd root or index. All right, class, if you're looking at this one, you're looking at a number that you square and you get to 64, is that right? What is that number? You're looking at a number that you have to square to get to negative 64. There is no such real number, right? So this one has no answer in the form of a real number, not a real number. And we will discuss that later on. Some of you may already know this is 8i, where I is square root of negative 1. Do you remember that? Complex numbers? Okay, don't worry about it. We'll have tons of fun with it. But as far as you're concerned for now, you're looking for a number, you square it and it becomes negative, there is no such real number, right? So you would say not a real number. However, if you're looking at a cube root of a negative number is a negative number, okay? Because negative 4 times negative 4 times negative 4 is negative 64, the answer is negative 4. Is everybody clear on that? In other words, class, cube root of negative 1 is negative 1. Or for that matter, any odd root of negative 1 is negative 1. Is this clear to everybody? So, when you're taking a root, if you're dealing with a negative number, okay, what's inside is called the radicand class, okay? This is the index. If the radicand is negative, then we have to pay attention to the root, the index. If the index is odd, there is no limitation. There's nothing to worry about. But if it's even, you better be careful. Go ahead, please.
So if it was, so because it's an odd number, it's not 4i, it's
No,
just
absolutely.
negative 4.
And here's a simple reason. Negative 4 times negative 4 is positive 16.
Mm-hmm.
Times negative 4 is negative 16. Does that make sense? For just to add that, for example, class, what is the fifth root of negative 32? Anybody? Negative 2. Okay? So if it's an even root, you can't have a negative. At this point, we will discuss it that it can be a complex number. Is everybody okay with that? Is this making sense a little bit? So be careful when you do things like that. Let us look at this example that I put up. Now, there are a number of ways to do it because you have been exposed to many exponential roots. And to me, the simplest way that I can do that would be using the order of operations. What does order of operation tell us? It says whatever is in there, okay, the grouping symbol is that parentheses, right? Simplify it first, then use the exponent, right? Use the parentheses before you do the exponent. So if I want to do that, let me deal with the numbers, 8 and 7. Let me deal with a. I have a to the power of 5. I'm going to multiply it by a to the power of 2. Notice, negative 2, I'm going to bring it down and make it positive 2. Is that right? And I highly recommend you take your time to do this step in order to come up with the correct answer. Now, b and b to the power of 7, we can cancel it, right? You get b to the power of what?
6.
Do you see that? I mean, that's a simple case. Because I don't have a negative exponent, I just simply cancel as before. Yes? What about the y to the power of 5 and y to the power of negative 5? Can I cancel it? Yes or no?
Yeah.
No.
Negative.
Why not? First, why not?
The negative.
They don't have identical exponents. If they had the same exponent, meaning both of them 5 or both of them negative 5, don't move them, just drop it. But they are not identical. They are different numbers. One is positive 5, one is negative 5. So keep y to the power of 5 and bring the negative 5 up, make it positive 5. Do you see what happened? And the reason I chose that number, because unfortunately that's a common mistake. Students, they see opposite numbers and they drop them. You can't do that because they have to be identical. Remember that? All right, so now we are going to simplify. This is 8, y to the power of 10, 7, a to the power of 7, b to the power of 6, to the power of what? The same thing, negative 2. All I have done is the order of operation. I simplified what's inside the parentheses, right? And I can't do any further. Now I do the exponent, which means flip it over and make it positive 2. Do you follow what I'm saying? That means 7, a to the power of 7, b to the power of 6 comes up. 8, y to the power of 10 goes down. Everybody agrees with that, right? So completely ignore the bottom, just look at the top. And squared, right? Look at the top only, squared. What do I write?
49.
7 squared, which is 49. Continue.
A 14.
A to the power of 7 times 2, which is 14. Go ahead.
B 12.
B to the power of 6 times 2. That is called the power rule, right? We're done with the top. What about the bottom?
64 y 20. So 25.
8 to the second power is 64. Y to the power of 10 to the second power is y to the power of 10 times 2. The power rule. I hope you're comfortable with the exponential rules class. I want to go to system of equations. Sounds good? Go ahead.
The 2 that are 3 problem, with the parentheses for the first one.
Where are we? Here?
2,
The 2 over 3.
Yes, this one? Are you done with this one?
Yeah.
Okay.
If the parentheses were replaced by brackets, would it make any difference?
No.
Or why do people use brackets?
It's just, a grouping symbol. Either way is fine. Whether you use, if you are using one grouping symbol, normally we use parentheses. However, if we use two, first we use parentheses, then we use brackets. If you interchange them, it's not a big deal. It has the same meaning. It is not a pair that may represent an ordered pair, or it might represent an interval. It might be an open interval, closed interval. That's not the case. It is just a grouping symbol. Whether you're dealing with the parentheses or brackets, it makes no difference. Sounds good? All right. Ready to go to the system of equations? Okay, so let's look at systems. We've already discussed them. And there are a couple of questions asked. We are going to cover. Systems. All right. Let's look at a couple of examples that they were asked. First of all, let's do this simple case, 2x. Is this from your sample test? I don't know, class. Yes or no? Check this out. Is this from the sample test? It is? Okay, so you have the solution to this. So to solve this, you can choose any method. Graphing, substitution, addition. But I hope you realize it's probably a better idea to go with the addition method or elimination. So tell me, what should we do? Give me an idea what you would do.
Multiply the first equation by 5 to give you a 10, and the second equation by 2.
Okay, so we want to multiply the first one by 5, the second one by 2. Therefore, which variable are we getting rid of? The x variable. So give me the first one, everybody.
10x minus 35y
equals what?
15.
So that's the first one. The second one,
Negative 10x plus negative, plus 15y equals 35.
equals what?
30.
14, is that right?
Oh, I'm sorry. I was looking at the 5.
So they are opposites and they cancel each other, right? Like terms, 10x and minus 10x. And what do we have here?
29, negative 21,
Equals,
29,
and y becomes?
negative 1.
Sometimes students, they stop here. You shouldn't, because you have to find x. And so to find x, let's say I'm going to use the first one. 2 times x minus 7 times y, which we found it to be negative 1 is supposed to be 3, right? And so 2x, this is what?
Positive 7.
Positive 7. If you subtract, you get what?
Negative 4,
And x becomes what?
negative 2.
Therefore, I highly recommend when you come up with that, put it negative 2, negative. Put it in an ordered pair, so you know which one is x, which one is y. Are we done?
Yeah.
No.
No?
Why not? Anybody? How do you check it? Into which one?
Either or.
No. The first one will not do the job. Why not? Didn't I use the first one to come up with the missing x? Therefore, the first one doesn't help you. You must check it with the second one, and that proves we've come up with the correct answer. Is everybody clear on that? Does it work? If you plug in the second one? I'm going to look at a couple of word problems somebody asked. And if there is time, we do a system of equations in 3 variables. I don't think we're going to have time today, but probably we'll do it tomorrow. In any event, a couple of questions that students asked. One of them was the mixture problem that we've gone over. The only thing is, it was, some part was missing. Prepare 90 liters of 48%. And we have, I don't know, 80% and what else. Is that what is the sample test problem on the mixture problem? Is that what we have, or who gave that question? Maybe you have a complete question you can ask, I can put it up. The one which is a mixture problem, it was asked. A chemistry lab assistant wants to prepare 90 liters of 48%. Unless you know, what do you have?
It says, a chemistry lab assistant wants to prepare 10 liters of 48% acid solution.
10 liters, okay. Okay, 10, okay, go ahead, I get it. Okay, continue.
In stock, he has 80% and 40% acid solution. How many liters of each in-stock solution should he mix to prepare a 10-liter mixture? And is asking to set up a system of equations to solve.
Okay, so let's see. We are mixing 2 types to come up with the mixture. So, actual or pure amount. All right. I highly recommend you come up with a table, class. So what are we mixing? The 2 types that we are mixing. What are we mixing? 80%, 80% and 40%. And the mixture is 40%.
48.
And how much of it do we get?
10 liters.
10 liters. So the volume is in liters. So if we want to go with a system of equations, we would say this is x, and instead of saying 10 minus x, we're going to say it's y, right class? System. And this one is what? Let's go with 0.8x, 0.4y, and then 0.48 times 10. Is that making sense? So let us write the two equations. Can you give me the two equations? X plus y equals 10. Okay. 0.8x and 0.4y is equal to what? 4.8, is that right? Now, I highly recommend you box this. So the first column and then the second column. So this is the first equation, this is the second equation. Many students forget to write the second equation, the first equation in fact. Sometimes students make a mistake here. If this was, let's say 8%, it means 0.08, okay? So that's something you want to be careful. But it's 40%. All right, so is everybody okay with the two equations? And now it's a system of equations we're going to solve. Since the previous one, we solved it by addition, let us do this by substitution. Okay? Any ideas what we want to do? The first one you're going to solve for x. Okay. If you solve for x, x becomes what? 10 minus y. Therefore, this becomes 0.8x plus 0.4 y equals 4.8. What is x, everybody? We just found it to be 10 minus. If you had solved for y, would be 10 minus x, and you would replace it. Okay. So what do we get here? 0. What? 0.8 times 10 is 8.
8 minus
8 minus what?
0.8y.
Plus 0.4y is equal to 4.8. And this will give us what? Negative 0.4y. Is that right? So 8 minus 0.4y is equal to 4.8. Yes, class?
Yes.
Subtract the 8, what do you get? Negative 0.4y equals, if you subtract the 8 from both sides, it goes away from here. On the other side, what do you get?
Negative 3.2.
Negative 3.2. Is that right, everybody? Divide by negative 0.4. And what is y?
8.
So y becomes 8 liters. Is everybody with me? So you have 8 liters of what? 40%. And x becomes what? 10 minus 8, which is 2 liters. And you must check with the second equation, making sure it's correct. Sounds good? Is everybody okay with that? All right. The next question that was asked. Is everybody done? Can I erase this? Here's the question given to me. It says we have a rectangle whose perimeter is 50 meters and whose area is equal to 24 meters squared. And they want to solve this. This is also a system of equations. We will look at this towards the end of the course. This is a nonlinear system of equations. I want you to know that. And basically, what it is that you write the dimensions as, I don't know, x and y. So do you see that the perimeter is 2 times x plus y, right class? So in other words, 2 times x plus y is 50, that's one equation. What is the area? Isn't the area the width times the length? Right? So x times y is equal to 24. That would be the second equation. And that's a system that we need to solve. To solve this also requires the techniques we've learned. Sometimes you use substitution, sometimes you use elimination, you name it, okay? So we are going to do the substitution. So let's do a couple of steps here. First, I'm going to drop the 2. That's okay with everybody? I divided both sides by 2. Then I'm going to solve for one of them. Let's say I'm going to solve for y. So y becomes what? 25 minus x. And I'm going to replace it into the second equation, which says x times y is equal to 24. So what is y? 25 minus x. So that will give us what? 25x minus x squared equals 24. In which case, I want to solve this. To solve, what do? We bring everything to one side and do the factoring. So let's bring everything to the right. Why? Because we want the coefficient of highest degree term to be positive. So it's x squared minus 25x plus 24, and factoring will do the job. We want two numbers. The product is 24. Excuse me. The sum is negative 25. Anything will do the job, class?
-1 and -24.
So x is either 1 or 24. So it is important to understand. If x is 1, which means meter, y is 24 meters. And notice the perimeter is 50 and the area is 24. If x is 24, then y is 1. No matter what the dimensions are 1 by 24 in any order. Does that make sense to everybody? Any questions? All right. I believe there was another word problem that students asked. Again, you have the question and you have the solution. You really have to spend the time on the solution on your own. But let us put it up. Then I'm going to spend a couple of minutes on synthetic division, as it was mentioned yesterday. I was going to do long division, but I don't think there is time. I hope you're comfortable with long division. Right. So I'm going to show you the synthetic division. Is everybody okay with long division? Oh God, I'm so well, let me do both of them in a second. But let me do the word problem that was asked also. And here's the word problem. Okay, we have a right triangle such that one side is shorter by 4. So if this is x, we're talking about the legs. And I don't know, what are the units? I don't remember if they gave me the units. But, let me see. What are the units that you have? Centimeters, okay. Centimeters. And we know the area is, the area is 70. So we want to find the dimensions. We know the area is 1/2 base times the height, right class? And if you have a right triangle, 1/2 times the sides. Right? One of them is the base, one of them is the height, right? Because they make a 90-degree angle. That would be what they gave us, 70. So the reason I box that, it's important that you do the same thing. Understand when you get to a very important part of the of your solution. So we just made up the equation, and therefore we are almost there. We have to just solve this simple equation. Everybody understood what I did here? The legs are missing. The relationship between the two is given. If one is x, the other one is shorter by 4, so it's x minus 4. And the area is supposed to be 70, so 1/2 base times the height. In any event, how do you solve that? First, let's get rid of the 1/2. How do you get rid of the 1/2, everybody? You multiply both sides by 2. Do you see that? Multiply by 2. 1/2 goes away, 70 becomes 140. Right, class? In other words, and now you have x squared minus 4x equals 140. Bring it to the same side for the sake of factoring. And can you think of this is fairly easy. How you factor this? You want two numbers. The product is negative 140 and the sum is negative 4. What are those easy numbers?
10 and negative 14.
Negative 14 and
10.
positive 10.
Yes.
So x is either 14 or x equals negative 10. And I'm going to cross out negative 10. Why?
Because it can't be negative.
Therefore, the answer is 14 centimeters and 14 minus 4. And you can see that the area is 10 times 14 divided by 2, 70 centimeters. All right, class. I'm going to quickly go over division, and I'm going to show you long division and simple division. And if there's any other question that you want me to cover, you can ask me, and I'll take it from there. All right, just quickly, long division. And at least I can erase this one, right? I'll choose a very simple example. Actually, let's see if I want to change. Let's see if this works. A fairly simple case. All right. Long division. And that's just a very simple example. To do the long division, first and foremost, we have to put the divisor and the dividend in descending order. Everybody remembers that one, right? Because if it's not given, we must change it accordingly. All right. Then we divide the first piece by the first piece. And that gives us what? This is a rough estimate. Okay, if you were to compare this to just a simple division, let me just put this up, a simple division that everybody knows. Let's just make up a very simple case. If you have, let's say, 250, and you want to divide it by, let's say, 8. Just making some number. Then you would divide in the following manner. You start with 2, right, class? Doesn't work. Then you go to 25, and roughly the answer is what? 2. 4 or 3, whatever you like. How about that? Then you multiply the 3 by 8, don't you? And what do you get?
1.
24, right? And then what do? You subtract 24 from 25, is that right? What do you get?
1.
So over here, the rough estimate using 2 and 5, we're going to use the first term only. Divided, you get x, then you multiply 3 by 8, you multiply x by x minus 2. Do you see the similarity? And it becomes what? X squared, what?
Minus 2x.
Minus 2x. Let's go back here. What did you do? You subtracted 24 from 25, didn't you? We are going to do the same thing. We're going to subtract this from the top. Subtracting meaning you can change the sign and add it. If I change the sign, and I really don't want to put the sign in front because I want you to see the original sign. Minus x squared, they cancel each other, plus 2x. So I have plus 2x and minus x, which gives me what?
X.
X. Do you see the similarity? What do you do next here?
Bring down to 0.
You drop the 0 and becomes 10, right? Now 10 divided by 8 is what?
1.
1
2 left over.
and 2 left over. Okay, so let's drop the 4. Is that the same concept? And roughly you divide x by x, what do you get?
1.
1. And then 1 times 8, in this case 1 times x minus 2 gives you x minus 2, right? What did we do? Subtracted 8 from 10, didn't we? The same thing, we're going to do the subtraction. So if I subtract, that means I'm changing the sign, and I get the 6. Now again, I want to show you the similarity so you see how that works. Going back to that, everybody. Going back to that. 250 divided by 8. I can say what? I can say the answer is 31 with the remainder 2, right? I can say 250 divided by 8 is 31 plus 2 over 8, and needless to say becomes 1/4, but stick with 2 over 8 because I just want to give you the concept. Or you can say 250 is what? 8 times 31 plus 2. Everybody understands what I'm doing with the numbers, right? Now here's what's happening here. I can say this is therefore equal to x plus 1 plus what? 6 over x minus 2. Do you see this is identical to what I wrote here? Is that making sense?
Yeah.
So this one, I'm going to put number 1 to it, next to it, and I'm going to put number 1 next to this. Meaning, just see the similarity. They're almost identical. The second case, I could say the following. X squared minus x plus 4 is what? The dividend. Okay? The dividend is equal to the divisor times the quotient plus 6. And I'm going to put number 2 next to it. Take a look at what I wrote as number 2 here. And take a look at what I wrote as number 2 here. Do you see the similarity? The concept is identical. Okay? And I'll go over the synthetic division. Same question. Take a look at it tomorrow. We'll discuss the synthetic division. It's not part of this course. You don't have to worry about it. Okay?